Taichung University of Education in Taiwan. And it's my honor to be here today. My topic is designing Chinese auto tutor for learning something about fractions. Okay, this is the outline today. First, I will give an overview of our study and talk about the research methods. And I will show some experimental results and also some of our future works. Why we choose the issue of fraction skills teaching to develop our own math auto tutor, since the learning of fraction skills in mathematics is relatively difficult, even for teachers to teach. Okay. The goal of our research includes, first, extended the application of auto tutor and why mathematical problem solving, because in the world, the application of auto tutor in mathematical area is relatively immature. Okay. And second, we hope to improve the operation skills of fractions, and especially this study focus on multiplication and division. Okay. And it is expected in the near future our system can be used to support the remedial instruction at school. Okay. I think this is maybe consistent with Professor Tsai have mentioned just later. Okay. Compare auto tutor to traditional classroom remedial instruction. More important, I think there is sometimes less interactions between the teacher and the students. There's less time to interact with each student. But in contrast, the auto tutor teaches students with auto tutor, each student will have his own individual learning processes. And moreover, I think in the traditional teaching, the teacher usually focuses on common errors of the whole class. Another one, auto tutor also is more flexible to be used. Once you have a computer with internet, you can use auto tutor to learn anytime, anywhere. Okay? But there's still a defect of auto tutor, because in our experiment we have found that some students were impatient to the tutoring procedure, since they have to compute by mouth and keyboard. Okay. In this picture, you can see that after traditional teaching, there are still some misconceptions haven't been taught. Okay. And with Math Auto Tutor, each one has his own individual adaptive instruction. Okay. I think this is the fourth time it appears in this conference. It includes the god of our research team, Professor Guo, has mentioned yesterday. Yeah. You just have remember that the inner loop is to the interaction with students to teach, and the outer loop handle which tasks will be given next and next. Okay. This flow chart shows how our experiment was conducted, and on the left side, at the designing stage, we use paper and pencil test to collect the real students' problem-solving processes, to collect the error types and misconceptions. And both correct and incorrect patterns were analyzed and classified for the designing of tutoring scripts, and to evaluate the effectiveness of our designed auto tutor. Of course, experiment was conducted, and in experimental group, students was taught with auto tutor and another taught with traditional teaching. Okay. There are 295 graders joined the test, And the paper test includes 10-word problems, which were arranged based on the knowledge structure of fraction. This diagram shows the structure of fraction multiplication from item 1, 2, 3, 4, and 5. Okay? And this one is the knowledge structure of division from item 6, 7 to item 10. Okay. Here are some general mistakes with their corresponding misconceptions we have found. Let me show you with examples. For example, sorry, too far. The question is, a bag of crackers is 6 kilograms in weight, and Wendy bought 1/3 of a bag. How many kilograms had she buy? Everyone knows the correct answer should be obtained by multiplication, but the student was misled by the special word "gong" in the context. This word means in total, so the student used an incorrect operator, addition instead of multiplication. What does it mean? In this example, a tutor or the teacher only has to give some hint about the context, not to teach the calculation right now. Okay, thank you. If we have time left, we can come here. Okay, before I introduce the designing principles of our system, I will show you how the system works when some user make correct responses. Okay, when the user make a correct answer and the computational process, a positive short feedback will be given by the agent, such as "Wow, you are so great." Okay, for further thinking, the system will give an interpretative question to the user in further, and for convenience, the user can answer the question by dragging adequate items from the text box to here, okay? And after that, the system will give a summary about the task, okay? According to GRACE 2011, there are 8 dialogue moves in a general auto tutor, namely short feedback, prompts, searching, corrections, answers, and summaries. And 6 of them were implemented in our system. Okay. Now let's look at the tutoring procedure of our system. Okay, the tutoring. Okay, I think I need a mouse. No. The tutoring program starts at the main question, and the user type their answer with detailed computational process. And then the tutoring procedure is divided into 2 parts. And the left module is designed for the user who make correct responses. And after positive short feedback, an interpretative question will be given for deeper thinking, deeper learning to the user. And here the inner loop will execute around whenever the user has some troubles. Otherwise, if the user has some mistakes at the beginning, he or she will be guided to the tutoring procedure to correct his or her misconceptions. And in this loop, the system interacts with the user by giving some hints or more clear prompts. Okay. And in this module, the inner loop will execute even 2 or 3 rounds. Okay. But if the student still cannot finish the task successfully, just behave like a the system will give a detailed instruction video to the student to learn. And most these two modules will be conducted to a summary about the task. And finally, the outer loop decide which one is the next task. Okay. For time constraint, I will show you the video directly. It's the same example as mentioned. Okay. The same example. Whenever the user make a incorrect answer, a hint will be given to encourage the user to try again. Okay, let's see it. That's why I say some students feel impatient because he has to input by keyboard. Okay, and then. Now the hint is given. Okay, if the user has the response still incorrect, a prompt will be given. And here we give an equivalent and simpler question with integers, which is easier. And we use diagrams to help the user solving the main question. Okay.
一盒蛋糕有3个，妹妹吃了有1/2盒，请问共吃了几个蛋糕？
So we have simplified the question and use diagrams. Okay. Okay. Whenever the user make this correct formula, he or she will be asked to compute the result in further. Okay. We ask the user to compute detailed. Okay. And you can see that the user makes some errors. The user used the reciprocal for multiplication is wrong, and another prompt should be given now. Okay.
你刚刚的算法有点错误，没关系，让我来帮你吧。一盒蛋糕有3个蛋糕，吃了1盒的算法是3乘以1，是吃了3个蛋糕。今天这题换成吃了有1/2盒，你的算法是3乘以又1/2。
What we are doing now, so here we try to make a conception conflict to let the user to find his misconception by himself. Okay, and the user, if still failed, teaching video will be given. Okay. Back to the presentation. Okay, now we'll talk some about the experimental results, and there are 35 students in the experimental group and 31 in the control group. Okay. And the result of the test of homogeneity regression shows that both groups are homogeneous. And the results in COVA shows that the score of post-test of both two groups are statistically significant. Okay? And estimated marginal means shows that the experimental results a group with auto-tutor makes better improvement. And furthermore, we divided the whole data into 3 groups according to. Okay. So let's show this picture. Okay. I'm missing my laptop. Thank you for your listening.
Can you go back to your the flow chart? I think it's 16 or so. Or maybe earlier. I'm sorry, earlier. The flow chart. Yeah, here it's up here. So I think one problem, a really big difficulty is how well do you understand the domain? And so I think for something like division of fractions, most people don't understand the domain. So when you ask people, what does it mean to divide a fraction? Most people can't tell you it's about changing the size of your container. So if you have 3 divided by 1/2, you're basically changing 3 into smaller containers of 1/2. That's how you get 6. You get 6 half containers, right? So in this situation, where if you start with a question, like a division fractions questions, and students do an answer, they don't get the understanding of what it means to divide a fraction until the very end often. Because this is the type of thing where it's just hard to figure out by yourself. But once you understand that dividing fractions is changing containers, it helps you with all sorts of things. For instance, let's say you get an answer where 3 divided by 1/2 is 2/3. Then you kind of know that that's going to be a wrong answer because you're moving from a big container to a small container. So this is something where the knowledge of the problem helps you. So even if you get the wrong answer, you know, okay, that's probably wrong, and you go back and check and change it. So I'm wondering where that is put in this area.
Thank you. Actually, the Math Auto Tutor in our research group, we developed different tutoring module and for addition, subtraction, and presented today multiplication and division. And also the understanding of the context of the word problem, like Jai and Professor Yang. We have different knowledge structure, different stage. So after the teaching, if students still can understand what this knowledge structure will what should to learn, the outer loop of the system should give a suggestion to previous task. Okay, I don't know if I have realized I understand your questions.
Yes, I'm sorry, I don't think that really addresses the question because the issue of so it's a problem of how this is used with the teacher. So I can see if you you explain the fraction idea, that dividing fractions is changing containers. Then if you do that beforehand, that might make sense. But if you rely only on the tutor to do it this way, it comes far too late. You really want to have that understanding before they do the problems, not after they try the problem. Right? So if this is used after a teacher does a lesson, I think that might make more sense. But if you're doing this before a teacher provides a lesson on division of fractions, you're losing an opportunity to help them frame an understanding of what division of fraction means. So the container idea is not specific to one problem. The container idea applies to all division of fractions.
Yes, your comment is right. Your comment is right. So that's at the very beginning, Zhijia just introduced that this auto tutor is used in diagnostic. After a normal teaching, then you used in the remediation. So it assumes the teacher already taught this kind of concept. So this is one of approach to design the auto tutor. The other approach is you design the whole classes at the very beginning. So we also have this kind of auto tutor. So then maybe they have to follow the knowledge structure, have clarify the prerequisite relationship between concepts. Then if auto tutor detect this student didn't have this kind of concept of skill, then through the outer loop, they will go to their prerequisite concept. Then that's what we do. Okay, thank you.
Okay. Any more questions?
About $10. Ask question. I have no money.
No money? Okay, now this time, for free this time. I'll give you for free. You want to take a chance? Sure.
No one has any question on the second question. So in terms of like the global understanding, like the example I mentioned before of there's like a sense of whether you know your answers are right or wrong or not. So I think part of here is that your the input you see is what the students type in. Can you go to the interface? I think probably line 18 or something. Yeah, yeah, right here. So here the interface is you type in the numbers, right? But you don't get to see the student thinking, oh, I know the answer has to be larger than 3, right? So you don't get a chance to see that. And so I don't know if there's some way to capture, because now you're relying entirely on the computation, is that right? Yeah. So that's another thing to think about. If students stop and they, oh, this can't be right, and they go back and change.
Regarding the metacognition, how they actually observe what they're doing. Okay, anyway, no, I'm just. Okay. Any other question? Oh, time's up. Okay. Just take a deep breath. Okay, there.
One, two, three. 1, 2, 3. Thank you. More, wait.
More.
1, 2, 3. Okay, one more. 1, 2, 3. Thank you.
Thank you.